The names of alkenes are derived from the names of the corresponding alkanes by changing their -ane suffix to -ene. Thus, the alkenes containing 2 and 3 carbon atoms are called ethene and propene, respectively. In the International Union of Pure and Applied Chemistry system, the longest chain containing a double bond is numbered so as to give the carbon atoms of the double bond the lowest possible numbers. Therefore, the position isomers of butene are called but-1-ene and but-2-ene, respectively.
More complex alkenes are named in a manner similar to alkanes. The alkene containing 6 carbon atoms and 1 double bond can form many different isomers. For example, 3,3-methylpent-2-ene, 2,3-dimethylbut-1-ene, and 3,3-dimethylbut-1-ene.
As we already know, the positions of the atoms or groups of atoms at the double bond in the parent chain decide whether the isomer is cis or trans. 2 isomers of but-2-ene are shown on the screen. Hydrocarbons containing 2 double bonds are called dienes, and those with 3 double bonds are trienes. They are named by indicating the position of the double bonds and inserting di or tri, respectively, before the -ene suffix. The examples shown on the screen are hexa-1,4-diene and 2-methyl-4-ethyl-hepta-1,3,5-triene.
Let us try to name the following alkene. At first, we identify the longest chain containing a double bond, and the number of carbon atoms in the way that gives the carbon atom of the double bond the lowest possible numbers. Now we identify one propyl substituent at carbon 3 and 2 methyls at carbons 4 and 5 respectively. Since the longest chain has 7 carbon atoms and the double bond starts at carbon 2, the full name of the compound is 4,5-dimethyl-3-propylhept-2-ene. Now look at this compound. The longest chain containing double bonds is made up of 6 carbon atoms. There are 2 double bonds located at carbons 1 and 4. 1 ethyl substituent on carbon 3 and 1 methyl on the same carbon atom. The name of the compound is 3-ethyl-3-methylhexa-1,4-diene.
The names of cycloalkenes are similarly derived from the names of cycloalkanes by substituting the suffix -ene for -ane. The numbering of the atoms starts at the carbon atom of a double bond and continues in the direction that gives the first substituent the smallest number.
Now, let us try to name this compound. When we move anti-clockwise from carbon A, we encounter a methyl group at carbon 2 and an ethyl group at carbon 5. However, when we start from carbon B and move clockwise, the substituents appear at carbons 1 and 4 respectively, which are the smaller numbers. Therefore, the name of the compound is 4-ethyl-1-methyl-cyclohexene. Notice that small cycloalkenes, cyclopentene, and cyclohexene can exist only as cis isomers because of steric requirements. However, when the size of the ring grows, the formation of a trans isomer is also possible.
The physical properties of alkenes are similar to alkanes, and they change continuously along the homologous series.
The lowest alkenes, from ethene to butene, are gases at room temperature. Those containing 5 and more carbon atoms are colourless liquids, with boiling points systematically increasing with the molar mass. Cycloalkenes are liquids too, with the exception of cyclobutene, which is a gas at room temperature. Both alkenes and cycloalkenes are insoluble in water, but they are soluble in one another. Their density is lower than that of water.